This is example 6 of the compounded interest and continuously compounded interest lab. For example 6, we have the following problem. Suppose $2,000 is deposited into an account that pays an annual interest rate of 8.2% compounded monthly, n equals 12. Find the number of years required for this initial deposit to accumulate to $6,000. So this problem corresponds with this type of formula. A equals P times 1 plus R over N to the NT, where A is the amount accumulated after T years, P is the principal or starting amount, R is the interest rate in decimal form, T is the time in years, and N is the number of times the account is compounded in a year. So we're going to find each of these variables in our problem. So first off, we have $2,000 is deposited into an account. So this is our P, or our initial amount. So P is equal to 2,000. Pays an annual interest rate of 8.2% compounded monthly. So this right here is our R. But remember, R needs to be in decimal format. So we need to move this decimal back 2 spaces. So it's 0.082. Compounded monthly. So in a year, it's compounded 12 times. So our N is 12. And then find the number of years. So we do not know what our T is. We want to find it. Required for this initial deposit to accumulate to $6,000. So this is our A, or our final amount. So we are going to take what we know and we're going to put it into our formula. So our formula is A equals P times 1 plus R over N to the NT plus. So our A was $6,000. Our P was $2,000. Our R was 0.082. Our N was 12. Then we have 12, and then we want to find our T. So first off, we're going to divide each side by 2,000. Try and get T alone. So 6,000 divided by 2,000 is 3. So you have 3 is equal to 1 plus 0.82 for 12 to the 12t. And this is when you may get stuck, because how do we bring down the t when this is not a natural base of e or anything like that? And how we're going to do it is we're going to remember logarithms. So if you've forgotten logarithms, we have a rule where, let me write this in red. We have a logarithmic formula where we have the log of base n of m, of value m, is equal to k, is the equivalent of n with the exponent of k is equal to m. And right now we have it in this format, but we want to write it in this format so that we can solve for our exponent per se. So we're going to find out which ones are n, our k, and our m, and then we'll write it in this format right here. So our n, since we have in this format here, our n is everything in this parenthesis. It's 1 plus 0.082 over 12. Could simplify that, but there's really no reason to. Our m is going to be what this is equal to. So in this format, we have this exponent is equal to 3, so it's going to be 3. And our k is the exponent, 12t. So we're going to rewrite what's currently in this format up here into this format right here. So we have log with base n. So this is base n of 1 plus 0.082 over 12. This is the base of value m, which is 3. A lot of parentheses. Is equal to our k, which is 12t. So now that we have it in this format, all we need to do to solve for t is to divide each side by 12. So we have a log of 1 plus 0.082 over 12 of value 3. And this is all divided by 12, so I'll just write 1 over 12 multiplied by it is equal to t. And once we plug this into our calculator, we get t is about 13.4 years.